Good day, welcome again to my online channel. Today's lessons, it's a continuation of structural frameworks. We have the first lesson from the previous video. Today we're continuing but with a different problem, which is a cantilever, right? So if we have a cantilever like this, remember cantilever, it's only fixed or supported on one side. Like here, this thing is only fixed here and there. Then on this end here, there is no support. So we call this thing a cantilever. So with a cantilever, as you can see here, with a cantilever, we don't need to calculate the reactions. So for a simply supported something like this, if you have something like this, which is simply supported, you have to start by calculating the reactions. But if this thing is only fixed on one end and then the other end is free, you don't need to calculate reactions, meaning that you can just go straight to drawing the vector diagram. So I'm going to start with drawing the vector diagram. Before we draw the vector diagram, make sure that you've named the spaces. This thing, we call it the space diagram. So you'll see that between this force and this force, there will be this space here. Then this space, we're going to give it the name. We're going to say this space, it's D. Then you name again between this force and this reaction force here, this space here, we will call that space E. So you name this force space between the forces. There will be reaction force here. There will be reaction force here. So between these reaction forces, this space, we call it A. And again, between this reaction force here and then this force, the whole space, this whole space, we're going to call it space E. So that is the first thing that you need to do. So sometimes the question will appear already having these spaces named for you, but sometimes the question they won't name the spaces. So the first thing to do will be to name those spaces. Right, so when you draw the vector diagram, we start with the scale. So the scale I've already indicated here. So the scale that I'm going to use will be this. 1 centimeter, which is this one from here to there, assume it's 1 centimeter. 1 centimeter will represent the 10 Newton. Right. So when you draw this thing, you start with the known forces or the external forces. I'm talking about this. I'm talking about these forces. So we're going to draw parallel lines. Those parallel lines will represent these forces. So like the first force that I'm going to start with will be this one. Then this force is having the magnitude of 45. So according to this scale, 45 will be equals to 4.5 centimeter. Then I'm going to draw a line with a length of 4.5 centimeters. So I'll start here. I'll start there for a length of 4.5, and I stop there. So that's what you must do. So we start from the top going down because this force is acting down. So your line must draw it going down. So as you can see, this line, it's between the space C and D. Then make sure that always when you name this thing, you must move clockwise. So this line, we're going to call it CD. So don't call this line DC. When you say DC, it's like you're moving like this, you're moving anti-clockwise. So this line, which represents this force of 45, we're going to call it CD. This space on this side is C, this side is D. So you move clockwise. You start from this side going in this way. So you'll have CD. So we're going to name this line CD. We're going to say this line, we started at C. Okay, let's leave it like that. This one will be D. Right. Let me see if I can move this. Yeah, I'm trying to move this C here. Yeah, like this. Good. Okay, let me leave D like that. So we are done with this force. Now from there you come to this force. This force is going down as well. Then we're going to draw a line parallel to this going down. So according to scale, 54 Newton will be equals to 5.4 centimeter. Then from here you'll go down and measure a length of 5.4 centimeter. Let me see if I'll be able to move. Let me move this ruler. Let's start here. Then from there you draw a line going down for a length of 5.4. So you start from here, you'll end here. So you draw a line starting from here to there, 5.4. So as you can see, this 54 is between C and D. So we're going to name this line was between D and E. We're going to name this line DE. So start from here going in that way. As I said, we must move clockwise. So this line, we're going to call it DE. Good. Then from here, we are done with the known forces. And now we have to find the space A, C, and D. Good. So to find maybe B, let's start with B. So to find the location of B, you will need to know the position of two adjacent spaces. So the adjacent space of B, I'm talking about this space on this side, and this side, and this side. So you can use any of these two adjacent spaces. Right now, you only need two, but make sure that those two spaces that you choose, they must be available on this line that we've just drawn here. So when we check, we don't have A on this line. We don't have A on this line at the moment, or on this space diagram. So this is the vector diagram. So this is the vector diagram. On this vector diagram at the moment, we don't have A, so we can't use A. So we have C, yes, C. We have D, yes, D. Therefore, to find the location or the position of B, we're going to use C and D because we already have them on this vector diagram. So this is vector diagram. Right. Now we're going to see, okay, before this, let me find the angles. Let's find the angles. Right. Uh, this angle is 140. This angle is 20. So this angle plus this angle plus this angle here, they must give us 180. So sum of angles in a triangle must give us 180. So that angle there will be equals to 180 minus 20 minus 140 equals to 20 degrees. So this angle here will be 20 degrees, will be 20 degrees. That is 20 degrees. Right. Let's find these other angles. Let's find this angle here. Let's find this angle here. I can give it any name. Let's say it's angle what? Okay, let me use it. Can be anything. Angle Q. So let's say angle Q. Now let's find the angle Q. So to find the angle Q, I can use this approach. Let me draw this. Sorry, I want to draw a straight vertical line. A straight line. Let me use this. If I draw a line like this line there will be parallel to this. So now this angle here, this one will be equals to this angle. Alternate angles equal. So it's like you have this, you have this, you have this. So this angle equals to this angle. So it's alternate angles equal. Then now to find this angle here, remember this angle is 90 degrees. From here to there is 90. Therefore, this angle will be 90 minus 20. 90 minus 20 will give you this angle. So this angle here equals to 70 degrees. So meaning that this angle as well here equals to 70 degrees. So now we have to find the Q. So let's find the Q. So what you can see here is that Q plus 20 equals to 70. So this angle Q plus this angle they are equals to 70. So then you'll say 70 equals to angle Q plus 20 degrees. Then from there, angle Q will be equals to 70 minus 20, which is 50 degrees. Then this angle here will be equals to 50 degrees. So angle Q equals to 50 degrees. So I'm going to use this space to draw my vector diagram. So let me remove this thing here. Right. This angle here, angle Q would be equals to 50 degrees. Good. Now let's move on. Now I'm trying to find the B. So we're going to say from C to B, there is a line moving at an angle of 20 degrees. So we're going to draw a parallel line from C. Remember, trying to find the B. So we're going to say from this C here, we're going to draw a line parallel to this. And then that line must move at an angle of 20 degrees. So you will come with your protractor. I don't think I'll need this. Let me remove it for now. You will come with your protractor. Here is it. You put it there. Then from here, you will mark an angle of 20 degrees. So here's your protractor. You measure. This is 10. This is 20. So we need 20. So you mark 20 there. As you can see, I've marked it with this dot here. Then from there, you remove the protractor. Then from there, you draw a line. You draw a line from this 0 to there. So maybe let me use the red line. Draw a line. Okay, let me use the red line. Still black. Yeah, you join this point with that angle of 20 degrees. Oh, anyway, let me use it. It's a construction line. Let me use a dotted line. Let me use the dotted line. So you'll draw a line from here, moving at an angle of 20 degrees. Make sure that that line project on both sides. It must project like this on both sides, like this. Right. So the reason I'm drawing this line from C at the angle of 20 degrees is because of this. To find the location or the position of B, I said that we are going to use two adjacent spaces, which will be this space and this. Then we'll check from C to B. There is a line at an angle of 20 degrees. That's why you have to come here at C and draw a line moving at an angle of 20 degrees. Or we have to draw a line from C parallel to this. So as you can see, this line is parallel to this. This line is parallel to this. Then after that, you come this side from D to B, or between D and B, there is a horizontal line. So from D to B, we don't know the location of B, but from what we know is from D to B, we are going to have a straight line. So you will come to B, here is B. You'll come to D, here is D. You'll come, here is D. From this D, we're going to draw a horizontal line because from D to B, there is a horizontal line. So from this D, we're going to draw the horizontal line like this. Good. So where these two lines meet is going to be point B. So these two lines meet here. So these lines are from C. We got this line by drawing from C to this. We've drawn a line parallel to this, which is this. Then from D to B, we have a horizontal line. Then we draw a line parallel to this horizontal line with this one. And then where these two lines meet will be point B. So this point there is going to be B. Good. Now let's find another point. We're only left with point A and E. Okay, let's find point A. To find the point A, the adjacent of this space, I'm going to use this adjacent space, which is E, and then this side, which is B. Then from E to A, you will have a line moving at an angle of 40 degrees. Then I will go to E. Yes, E, I'm going to draw a line parallel to this, but that line must move at an angle of 40 degrees from vertical. So this line 40 degrees, it's from this vertical, it's from this, it's from vertical. Therefore, as well, the angle that I'm going to measure here, I must measure it from this vertical line. So I must measure 40 degrees from this vertical. I can use the protractor as it is, or I can turn it around. So if I use it like this, I will just count and say from here is 10, 20, 30, 40. So this will be my 40. But if you want to turn it around, it's fine. I can turn it to a different direction now. Yeah, good. So you can put it like this. Then this will be your 10. This will be 10. As you can see, it's 10, 20, 30, 40. Your 40 will be there. So after that, you remove this, remove this one. Okay. Uh, this is 40. And from there, let's move this protractor. So I'm trying to find the A from E to A, there is a line moving at an angle of 40 from vertical. So from E, I'm going to draw a line moving at an angle of 40 degrees measured from a vertical line. So that line will move like this, crosses there, crosses there. So let me just pull it because I don't know where this thing is going to meet with that other line. So we'll do it like that. Okay, from there, from B to A, from B to A, there is a line. In between, there is a line moving at an angle of 50 from the vertical. Right. Then you'll come with a protractor. We go to B. Yeah, here's B. Let me take the protractor and put it there. Let me turn it. Put it there at B, like this. Right. So now we have to find this angle here. Maybe let's find this angle here. Let me draw a line. If I construct this thing like this, can we find this angle here? From here to there, this angle. So this angle is going to be 90 minus 50, which is 40. Or you can say this angle plus this angle must be equals to 180. Sum of angles on straight line, 140 plus 40, 140 plus this unknown angle must give us 180. Then we'll have 180 minus 140, which is 40. Therefore, this angle here is 40. From the horizontal to this line is 40. Then you'll do the same thing here. Remember, we have to draw a line parallel to this. The line that we're going to draw now must be moved at the same angle with this. So this angle is having, this line is having an angle of 40 from horizontal. So we'll do the same thing from horizontal. From this line, we're going to measure an angle of 40. This is 10, 20, 30, 40. 40 is there. 40. Then you remove your protractor and then you draw a line from here like that. Then where these two lines meet will be A. Will be A. So this point is going to be A. How did we find this A? We said that to find the A, you will use this adjacent space. Neighboring space of A is B and E. You can't use C. To move from A to C, you'll jump B. So C is not the neighbor. You can't use D. To move from A to D, you have to jump some spaces. So neighboring spaces E or adjacent space E and B. So we'll say from B to A, there is a line moving at an angle of 40. Then you come here, you come to B, here's B. You draw a line moving at an angle of 40. That line, this one is parallel to this. Then from there, from E to A, you come to E. From E to A, there is a line moving at an angle of 40, which is this. So this line that you see here, it's parallel to this. So where those two lines meet, this one and this one meet, it's going to give us the position of point A. Right from there, we have everything. Yes, we are done. We have A, we have B, we have C, D, E. We have all letters. From A to C, we have it here. So from this now, we just have to join the members in this way. From, okay, members, I'm gonna have this line from here to there is member, from here to there is, we're going to call it the BC. This member, we're going to call it the BC. So you'll come here and make BC solid line. This is B, this is C. You make it solid line like this. These dotted lines are the constructions line. Then after that, you come to this member. This member is from here to there is AB. So you make it, you join A and B. So you'll have this. Then this member from here to there is member EA. Then you'll join E and A like this. Then from here, this member here, from here to there, it's D. Then you'll join B and D. So get this one. Then that's all. That's all. Then these dotted lines here, you can erase them. You can erase them. But if you made them light, you can leave them like that. Let me see if I can try to remove them. Good. But remember, this is A. It's going with my data now. Let me leave it. Let me return it. Okay, it's fine. Yeah, this solid line that you see there is our vector diagram. So now after doing this, you have to, we didn't answer the question. The question is looking for graphically determine the magnitude and nature of forces in the frame shown below. So we have to find the magnitude. So to find the magnitude in the members, like if you want to know how much will this member BC, this member from here to there carry, you'll measure from B to C. So from where is B? Measure from B to C. You have to take your ruler and measure from here to there. And after that, don't forget to multiply your answer by your scale. Let's say, let me see if I can bring the ruler. Yeah, you will take your ruler like this, measure from here to there. Like that. It's about 15 centimeter. Then we said that 15 centimeter equals to 10 Newton. It might be 152 or 150 something. Let me just check how much did they get. This is member BC. Which is this? Yeah, so they got 131. They got 131. So that means yourself you have to get 131. So the difference here is due to the fact that I've been doing some zooming. I did some zooming here. So that zooming led to this kind of difference. So actually it was supposed to be like this. Yeah, let me leave it like that. So if you measure from here to B, you'll see it's about 130 something, 131. So that's what you must get. Right. If you want to know how much will member EA, this member here, we're going to call it EA, carry, then you just have to measure from E to A. From here, from E to A. Then you will take your ruler again and turn it. Then measure from here to there. It's about 12 centimeter. About 12 centimeter EA. Let me see what they got here. Yeah, EA 12 centimeter, which will be cost 120 Newton. 120 Newton. Right, so that's how you determine magnitude. Then you will continue with the rest. You just have to measure. We did EA, we did CB, then you will measure these ones, these two yourself. Now, as you can see, now we have to find the nature as well. Nature, we have to find whether a member will be under compression or the member will be under tension. So you will check it in this way. Right. We're going to consider a joint. So you will choose which joint to start with. It's really up to you. But if you don't have much experience, you can start with this joint where you'll have less members on it. Let me remove this. Okay. Yeah, let me use this. So if you check this joint here, you are going to have three members or three forces acting on this. You will have 1, 2, 3. But when you check this joint here, this joint, you will have 1, 2, 3, 4 members. So now let's start. Let's choose this point where you will have lesser members. this one here. Let's consider this joint. Remember this space here is still space C. This one is D. This one is B. So this is B. Right, we're trying to find whether a member will be a strut or tie. So you can start at any point here. You can move from here to there, from B to C, or from C to B, or from D to B. So wherever you start, make sure that you move clockwise. So don't start at D and then from D you say you move to C. You will be moving anti-clockwise. So maybe let's start here from B to C. You will come here on this vector diagram and check and move from B to C, from B to C. So from B to C, you will be moving in this direction. You will be going up. You will be going up. So because when you move from B to C, you are moving up. Then from B to C as well here, we are going to draw an upward arrow there. So we'll draw an upward arrow like that. Then from there, from C to D, you will come here and check from C to D. When you move from C to D, you will be going down. From C to D, you will be going down. So that's why this arrow is going down. So it's already there. The direction is already there. Then from there, you come here from D to B. From D to B. When you move from D to B, you will be going in that direction. So from D to B, you'll be going in that direction. Then that's why we're going to draw this direction. Right. So if on the other end, a member is, the direction is like this, going like this, the other end will go like this. So on the one end, on the other end of this member, remember talking about this member BC, which starts from here to there. So on this end, there is this direction which is pointing up. So if this thing is pointing up, on the other end, then this thing will go down. So they're moving towards each other. So if you have a member like this, if on the other end, this arrow is moving like this, then on the other end, the arrow will be like that. So they will always move in opposite direction. So if one end, the direction is this direction, the other end will be in opposite direction. So like here, we have this direction here, we have this direction, so the other end will take this direction. And then we're going to say that, or if a member is having this kind of directions, this member like this one, we're going to say it's a tie, represent a tie. Then this one, it's a strut. So I spoke about these things from the first lesson. I can quickly just go and remind you. Yeah, so this is where I've discussed the what is a tie, then what is a strut. So a tie is a member in a state of tension. Then to determine, or let me just write, to determine whether the member is a strut or a tie, we use the internal forces. We use the internal forces. So if you have this and then you stretch it like this, the material will develop internal force will pull in opposite direction like this. Then we use this to determine whether a member is a strut or a tie. So if you have something like this thing, we're going to say that that member it's a tie. So if we have internal forces like this, we're going to say that member it's a strut. Or from those arrows that inside the cycle, if you check those arrows inside the cycle, if an arrow is pointing towards the joint, then we're going to have a strut. If an arrow is pointing away, so let's say you have a joint like this, okay, like what we've just done, we had this, we had this, we had this. I made the cycle like this. I don't remember very well. Okay, for anyway, let's give an example. If an arrow is pointing like this towards the joint, then you must know that this member is going to be a strut. This member is going to be a strut. Then if the arrow is pointing away, then that member we're going to call it a tie. So we're going to call this member a tie. So it works like that. It works like that. Right, back to our problem. So this one, as you can see by these arrows here, as you can see by this one is going to be this. So this member, we're going to say it's a strut. It's going to be a strut, this one. Then this member, the arrows are pointing inward or towards each other. If they are pointing towards each other, then this member, we're going to say it's a tie. It's a tie. So, okay, let's just confirm with the what these guys got from the memo. This is BD. BD, it's a strut. We got strut. So here is it. BD, it's a strut. And this one is BC. BC, it's a tie. So here is BC. BC, it's a tie. So lastly, let's consider this point here. This is E. This is A. This is B. So to determine the nature, we're only left with this member and this one. So to determine the nature, you'll say you will move clockwise. Let's start from here. You can start at any point. Let's start from E to A. From E to A, you will come here and check from E to A. You will be moving up. So you will be going up. Then you will draw an upward arrow there. So this arrow is moving towards the joint. So what did you say about a member that moves towards at the joint. We said that the one that moves towards the joint, it represents a strut. So, but anyway, if the other end, the arrow is going up, on the other end, the arrow will go down. So these arrows are moving away from each other. So if they're moving away from each other, we're going to have this. So this is going to be a strut. Then we come again and move from A to B. When you move from here to there, from A to B, you come and check here. From A to B, from A to B, you'll be going down. So you'll draw a downward arrow there. So that means this thing now is moving towards the joint. So if it's moving towards the joint, you are going to have a strut. So meaning that AB it's a strut, EA it's a strut. So you'll have 3 struts and 1 tie. So the only tie will be that one. Right. Thank you very much. Thank you very much.